list the different steps. You did this one. Did you do this one?
She said we should try it.
Okay, all right. So let's see, it says, will a solution of, now I want the name of that thing, Bontle.
Sodium bicarbonate.
Sodium bicarbonate or sodium hydrogen carbonate or bicarbonate of soda. All right, will a solution of bicarbonate of soda be acidic, basic, acidic or neutral? Use hydrolysis to fully explain this answer. Now, when they give you a question like this in a test, now see, ma'am didn't do it completely like this. They want you to give an equation as well. Okay, right. So will the solution be acidic, basic, neutral? And explain why. It does what? What's the first thing you do? There's different steps. You identify the ion. So you take sodium bicarbonate and you say, right, you have the sodium ion and you have the bicarbonate ion. Okay, so you split it up into the two ions, the positive and the negative ion. Next step is you say, which one comes from a weak base or strong acid or strong base or weak acid, whatever. Okay, so let's check. Sodium comes from a strong base. So sodium ion comes from sodium hydroxide, which is a strong base. And yeah, bicarbonate ion comes from a which is a weak acid. Okay, so that is why there's a list of acids and bases at the beginning of the chapter, I think, that you should go study. Weak, strong, weak, strong, weak, strong. Okay, so we have a strong base, we have a weak acid. So the strong base, what will happen with the strong base? It will not undergo hydrolysis. So you say that sodium ion does not undergo hydrolysis. Do I spell it correctly? I don't know. I don't care. Does not undergo hydrolysis. But bicarbonate does. And then you show how it undergoes hydrolysis. Now, hydrolysis is how it reacts with water. Okay, so you take this ion, it reacts with water. This is a reversible reaction. So there's two arrows. And then what will you get, Bukamuso?
We're going to get hydronium ion.
And?
CO3 minus ion.
How many minuses? Two minuses. Carbonate ion. Okay. So, there's something that must jump out of the page to tell you, bing, 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 this is linked to this. What is that that's jumping? Klonu?
What's that jumping?
I don't know. I'm asking you. What forms that causes a lot of things? When I say Marx, you say?
Physics.
Marx? Marx? If I say acid, you say?
Base.
Yeah. If I say acid, you say?
Oh, hydronium.
We did this last year.
No.
Nee?
No.
Okay, well, this is the face of an acid. When you see that, you think acid. I feel we did do this. But anyway, so when I say Marx, you say science. Or when I say Einstein, you say science. I don't think I'm the face of science. I thought you got to say when I say Marx, you say white shoes. I always wear tackies. That's what the one near the group says. Okay. Right. So you see this and immediately say, all right, because it forms hydronium ions, and because hydronium ions are the face of an acid, it will cause the solution to be acidic. Okay. Sorry, so let's just check here. So it says, there's the equation that it undergoes. It says there the forward reaction will be favored above the reverse. You don't have to say that. Okay. So you don't have to say that much. But because the salt is acidic, because it produces hydronium ions, thus the pH will be less than 7. Okay. So because hydronium ions are formed, the salt is acidic and the pH will be lower than 7. Okay, now the past couple of years, I think the past 2-3 years, they did not ask this question like this, but before that they did ask it a lot. And remember, they said you have new people setting up your question papers. So they might revert back to this. Yes?
So when you say the solution is the salt,
The solution?
like the solution is an acidic because
Yes, that's one. Yes?
Since the N is from OH minus and it's a strong base, I thought neither would undergo hydrolysis because Na comes from a strong base.
So that will not undergo hydrolysis, but how can you say neither? Neither refers to two things.
So can't we say sodium?
So sodium won't undergo hydrolysis, but remember, we're busy with this thing. So I'm not busy with this thing, I'm busy with this thing. In this thing, that will not undergo hydrolysis, but this will undergo hydrolysis. Okay, so you don't look at this, look at that. Okay, there you did one multiple choice. Let's look at the next one. It says, consider the reaction of acetic acid or vinegar with refill. No, there's not an acid. What's this?
Base.
No. Nitrogen is in. And this? Yes? Yeah, hydronium is this. No. Sodium hydroxide. You must go study your names. Grade 10. Consider the reaction of acetic acid with sodium hydroxide. Which one of the following net equations account for the pH of the salt? Account for the pH of the salt. Okay, right. So, this is not a salt. This is not a salt. Where are they going with this salt? Remember, at the beginning of this chapter, somewhere, somehow, here, you said an acid and a base will always give you salt, 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 and something else. All right. So they are saying, okay, you add two things together. You are adding this acid and this base, and it will form a salt and something else. What salt will form? Let's check. So it's going to split up there in the negative and positive ion, and it's going to split up there in the positive and negative ion. What's going to form? You're going to get water. Yes. And this is the salt that will form. So you have this thing here is the salt. Okay, so they ask which one of the following net equations account for the pH of the salt. So the salt we want to check will split up and part of it will form or undergo hydrolysis, right? Will it be the negative ion or will it be the positive ion? Sodium comes from a strong acid, base. It will not undergo hydrolysis. This one, this is, acetate ion, comes from a weak acid. It will undergo hydrolysis. So it's the weak one that will go undergo hydrolysis to form that and that. It's going with?
Can you start again? Because you said
Oh.
that one.
I see.
Acid base.
Yes.
they form a salt. And they want to know what is the pH of the salt.
Okay.
Okay, so we need to look at what was the salt that formed. This will not undergo hydrolysis because it's from a strong base. So this ion will undergo hydrolysis.
Okay.
Sharp?
Yes, sir.
Cloney, you must not make me excited with oh and
No,
okay.
I get it. I get it. But
Okay. Done. All right. Okay, next one is acid-base titration reactions. Okay, so this is what this whole chapter, the big thing of this whole chapter, what it is about. Okay, now a titration reaction is when you have something like this. Now this is a stand. This is a big thing that measures correctly. What is this thing called? No, the small one is a pipette. This one is a burette. Pipette, small. Burette, big. Alright, okay. So we do titration reactions with this. Who's the tallest in this class?
Me. Or doesn't? I'm the shortest. I'm the shortest.
Or someone must stand on a chair. Yeah, stand on a chair. Get a chair. This is a what? Alan Meyer flask.
Doesn't even know this
Alan Meyer. Yeah. Okay. Now let's add there at the top. Let's add the base. The base I'm going to add is sodium hydroxide. Okay, 0.1 molar concentration. So it's not that concentrated. Okay, you're going to add that there.
Can we just stop now?
Okay, you can stop. Okay, so if you would have done, you can sit down. If you would have done a full titration, you would have added the base all the way to the top. Then at the top it says 0. And then as you let go, as you open the cap here and you let some of it out, you can count, add, read how much you've added to the solution. Okay. Right, now in here, so what you normally do is you want to know what is the concentration of an unknown substance. You want to get it to a standard solution. You want to make a standard solution. Okay? So let's say I do not know what is the concentration of the base here that I've added. Okay? Then what I'm going to do is at the bottom, I'm going to add some acid that I know the concentration of, and I'm going to add the exact volume. Okay? So I'm not going to be very precise now, but if I want to know what is this one's concentration, I need to know exactly everything of the acid down here. Okay? I need to know the concentration, 0.1 mole, and I need to know how much I add, which I don't know what I'm now. Alright. So now we need some way an acid and a base will neutralize each other, right? So we need an indicator to help us to see when it's neutralized, because this is colorless, this is colorless, no idea when it's neutralized. So I'm going to add an indicator. Now, have you done indicators?
Yes.
Yeah. Yoshonu.
I was absent.
Yeah, you were very much absent.
Yeah.
Right, so there are the 4 indicators that you need to know. There's lots more. There's like a world of indicators in life. Okay? These are the 4 that we use in science class. We have methyl orange that we use when we are busy with something that is a strong acid and a weak base, meaning we get to a low pH. When we are, when it's equal strength, more or less, when the pH is more or less in the middle, then we use either broom blue or we use litmus paper. You remember litmus paper you're using grade 8 and 9? Yes. Right? That is when you use that. And then you have phenolphthalein. You use when you have a strong base and a weak acid, meaning you end with a high pH. Alright. Now, today I said we are going to add sodium hydroxide, strong or weak? Strong base. And what's HCl? Strong acids is hydrochloric acid. So strong acid, strong base. Which indicator is suitable for this reaction?
This one will be neutral.
We want it to get to neutral. Okay. So in here I have what did I add here? So what color will it be when I add Brimful blue? Yellow. It should be yellow. Okay, you can see when I start it's blue. Brimful blue. Yellow. Okay. Right, so there is my yellow, very much an acid shot. Now I'm going to slowly add the base until it changes to what color? What color will it be when it's neutral? Green. Okay, so when you add it, okay, you swirl it. Swirl. Okay, now I want you to come stand closer, please.
Instant. Takes time.
That's what I wanted you to see. No, it's not COVID. Come. Okay. Right. So normally it takes one drop for it to change color. Okay. So what? I think I need to not add enough base. Can you see the blue?
Yes.
Oh, yeah.
No blue.
Yes.
See the blue?
Yes.
Okay, why is it blue and then it goes away? Because the base falls there, so the base is concentrated until it dissolves or it undergoes diffusion. Right, you remember that word?
Yes.
Okay, then it goes back to the acid because there's more acid particles. See the blue? Actually, I should do twirling this the whole time. Yeah. Twirling.
Again.
To get back on the chickens. I think the teacher did not learn this weekend.
Tell me to stop now. Is it closed there?
Yeah. Yeah, gooi maar. Go.
Others.
Guys, shut up. Are you and others are speaking to?
Yes, man. Always.
On terms.
What?
On best friend terms.
Okay. Swirling it.
It's becoming lighter though.
Okay, so when you actually do the experiment, like in an exam, she did not add so much like I'm doing now. Speed it up.
It's dark green. Is it blue?
Joe, how many acid did you add?
Okay, so now you know you got close.
Yeah.
Okay, so now you go drop. Drop.
There you go.
A few drops later.
It's almost there. It's a bright yellow now.
This experiment.
Does this count as green?
This is a light green.
No, it's like a light blue. Yeah,
That's
Okay, so this will be, I'll say this is green. This will be the equivalence point or the end point of the reaction. Okay, when it's neutralized. And when you add too much base now,
it's too bad. It's green.
blue.
It's green.
It's rounded.
so when you add too much base, it will turn to blue, and now the solution is basically. Now I've got.
It's green.
Okay, so I know.
Yes. You only missed
Okay, so the reason why it's going back all the way like this is because I'm using very diluted acids and bases. Okay? If I use something that's a bit stronger, then one drop will change the whole thing. Okay. So, in the science curriculum, you must do one chemistry and one physics practical. We've already done the chemistry practical. Then we did the esters. So this would have been the other choice for a chemistry practical, which we're not going to do. You're going to do circuits. So you would have done this in an exam. You would have done this 3 times, okay? Because the more you do it, the more accurate you get. Because you would have seen, if you've done it the first time, then you've accidentally added 2 milliliters too much. And then the whole thing would have changed colors, and then you would have filled this up again, threw this out, and then start again until you get that one droplet that just changes the color. Okay. Now the reason I'm telling you this is because they can ask you that in the test room exam. Okay, so you do 3 times. Why? For accuracy reasons. This is the added flask. This is the burette. Here you measure how much you add. This one at the bottom, you know the volume that you've added, so that you can calculate the unknown concentration of either one. Okay. Are you with me? Right, okay, go sit down. Okay, so this reaction is called what again? An acid-base titration reaction. A titration reaction, another name for it, and this process is also called titration. Okay, so when you hear the word titration, you must think of this. This is almost like in my head, this is an upside down T. Okay, if you ignore the funnel there, this is the line of the T, and this is like you need the elevator flask and the burette. Anyway, it's in my head. Okay, so this is a neutralization reaction. Why? Because it's an acid and a base. Now, neutralization reaction does not necessarily mean you have to end at a pH of 7. So it does not mean you have to make this whole thing neutral. It just means an acid and a base neutralize each other, or they cancel each other out, in a sense. Okay? But the pH does not have to end at 7. Okay? It ends where the acid and the base meet each other. If you have a strong acid, strong base, yes, it might be 7. But if you have a weak acid and a strong base, it might be at 11. Okay? The end pH is dependent on the strength of the acid and the base used in this reaction. And the end pH will determine the choice of indicator that you use.
So, ma'am, here the indicator was from
Blue. Broom-thermal blue. Okay, 2 definitions here. The first one there is equivalence point. The equivalence point is the point at which the acid has completely reacted with the base. Okay, where all of the acid has reacted with the base. So it says where every hydrogen ion has an OH ion, where they've paired up, they've moved inside, diffusion has taken place, and they've met up, they've paired up. Okay, and then we have the end point. The end point is where the indicator changes color. Okay, so these 2 concepts do overlap, but they're not the same thing. Equivalence point and end point. Okay, now in this part of the chapter, you can have or you can draw graphs. Now they will not ask you to draw a graph, they will give you a graph. Okay, for example, this one is like we just had. Just the inverse of what we've had. Okay, they say here, we have the volume of 0.1. This capital M stands for molar concentration. Okay. Now concentration, we usually write the unit for concentration as moles per decimeters cubed, right? But that is very long to write down. So in the science labs, not in your answer sheet in the exam, but in a lab, instead of writing mole per decimeters cubed, we just write a capital M to say that it's the molar concentration. Okay, so you can see here on my bottles, I've written down capital M instead of writing mole per decimeters cubed. Okay, right. So here they say we have sodium hydroxide, and then on the y-axis we have the pH. Okay, so here we start, with 0 sodium hydroxide. Okay, sorry, this is actually exactly what we did. Okay, and they say this is a titration of a strong acid. So what this means is at the beginning, we have had a strong acid in here. What volume of the acid? We don't know. What concentration? We don't know. It's not written on this table here. But practically, we do know. So we can say the strong acid, for instance, is hydrochloric acid. And we have added, let's say, we have added 25 centimeters of 0.1 mole, for example. Okay, are you with me? Centimeters cubed is the same as milliliters, because our thing is in milliliters. Alright, so this is what I have here. What will the pH of this solution be? High or low? Very low, because it's just the acid. Low like in 1. Okay, have I added any base? No. So the volume of that added is 0. So the pH is low. Now I add a little bit of base. Did the color change already? No, it stayed yellow. So it stayed a low pH. Okay? Low, 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 low. Until at some point, when I've added some sodium hydroxide, then the color changed. Yes? Then it was the end point where we had green. And then when I added too much of the base, it changed it to blue again. Yes? So I can ask you, how much base was needed to neutralize the acid? 25 milliliters. Okay. I'll be with you in a moment. When 40 milliliters was added, was the solution acidic or basic? Basic. How do you know? The pH was high. Okay, how do you know it changed color? You can't see on here change color. We know it changed, but how do you know that? The information given tells you the pH is high. Okay, here's Klone.
Ma'am, so the end point starts at 2 or 3. Because for it to be neutral, it has to be at 7.
So, yes, so the end point is there in the middle of there and there. In the middle of it is the end point, or the equivalence point. Okay. Right, so we said a suitable indicator between a strong acid, like hydrochloric acid, and a strong base is what? Suitable indicator? Bromothymol blue. What color will it be when it is there at a pH of 1? Yellow. And when at the equivalence point? Green. At the end point? Blue. Okay, now here is the titration of a weak acid and a strong base. Now this is what we would have done if we did the practical. And the indicator you would have used is phenolphthalein, because it would have been acidic acid with sodium hydroxide. Okay, what did I say at the bottom? Was this hydrochloric acid? Okay, right. So we would have had phenolphthalein is what color when you add a base to it?
Pink.
With a base?
Colorless. It's colorless and acid. Purple. Oh, purple. It's pink in the base. It's pink in the base.
It's pink in the base and colorless and acid.
Yes.
So it's acid. I'm just quickly going to do it so that you can see the color change. Okay, phenolphthalein. Okay, so there is the base. No, sorry, the acid, colorless. Okay. Now, when I add the base,
the base or can it be a base then add acid?
Yeah,
It's
yeah.
the same thing.
Yeah.
True, that's a highlight.
Alright, so you see the color pink that it changes. So there's not it goes from pink and then purple. It's colorless and pink and then a light pink in between. Okay, the first glimpse of pink is the end point. Okay, right, so naphthalene.
Where are you going to get another solution?
I make it.
What do you normally make it?
So, in the practice, what's your method?
That is the word like science.
Okay. So here is sodium hydroxide. It has this label on, and that label says corrosive, meaning it eats away your flesh. Okay? So it's the small pellets. It looks like polystyrene balls, they're small plastic balls. Alright? But it's not that. It is, when it falls on your hand, it starts to itch and it burns. Okay? And if you add water to it, it burns even more.
How can you
Okay.
do it?
You must rinse it off quickly with a lot of water to dilute it a lot. But if you rinse it with a little bit of water, it actually performs an exothermic reaction, so it heats up and it burns at the same time. Alright, so what I do is I take some of these pellets and I dissolve it in water to make the solution.
Oh.
Alright?
So then how do you know it's the same concentration?
Because you can calculate concentration, can you not?
Okay.
C equals
Yes,
to
bro.
M.
A number thing.
Okay, so if I want to get a concentration of 0.1, okay, and I know the molar mass of this is 40, and let's say I'm going to dissolve, I want to get 1 liter.
Okay.
What mass must I measure way off to get a concentration of 0.1? What?
Good.
What how much?
M. Oh, what do you want? You want M, right?
I want A. What did you say?
Oh.
4 grams. Yes. I said 4 grams. And this would have been part of your practical. I would have just set this here and said, okay, there's a scale. Please make a concentration of 0.1. Then you should have calculated how much must you weigh off, measure it, and then put it in an aluminum flask and swirl it until you get the exact volume of 1. Because if you change the volume, if you add too much water, too little water, the concentration changes. Okay, and then with that one, you would have determined this one's concentration. I would have not put the sticker up. It says plus minus.
Yeah.
And then you should have determined this one's concentration in the practical. It's a very difficult practical, not a lot of people get it right.
Are you going
So-
to give it to the people,
Next
the
year.
kids next year?
I'm finishing up this year.
Yes?
I'm not coming up, I'm not coming back next year.
That's happening. M is so light. Okay, okay.
Just wait a moment.
So I don't know what the teacher's going to do next year. She or he can do it. Whatever they want to do. Alright. Huh?
So you're living with us.
Yes.
She came with us.
You came with us, you're living with us.
Yes. Alright. Okay. So here is the titration of a weak acid. For example, sulfuric acid, acetic acid, with a strong base like sodium hydroxide. Weak acid, strong base, your gut feeling or your knowledge should tell you that we are going to use phenolphthalein. Phenolphthalein. Is that how I spell it?
Yes.
In the Afrikaans we use. In English,
There's no?
between the I and the N.
What? It's
The
like
E's.
L-E-I-N.
Doesn't matter, you need to know how to spell it, not me. Get this one. Alright. Should know that you're going to use this indicator. Yes, you need to know to spell it. Right. So you can see at the beginning when we had no base, The pH was low. Why? Because we were busy with an acid, but it's not that low. It's not a strong acid. It's a weakish acid. And then as you add the base, the pH goes up, up, up until you get the equivalence point, and then at the end you get a more basic solution. Okay, here it was colorless. Here it was a light pink. And here it is a dark or a bright pink.
Why do you say purple?
Maybe you can say it's like a unicorn purple. Nee? Barbie purple? Okay. Right. The next page. This is the calculation of the unknown concentration or the calculation of the titration reaction. Okay, right. So here I just gave you how I got to this equation. This is an acid plus a base, gives you salt and water, right? Now that is not a typing error. That lowercase a stands for the coefficient. Like if you have 2 hydrochloric acids plus... Okay, right. Now, to get concentration, we have two calculations or formulas. So we have this one and we have this one. Yes?
Yes.
Yeah. Right. So, I can take this equation and I can rearrange it so that I can get N is C times V. Right? Okay, and that is where we get to this equation here. This here is a fraction, and fractions are just relationships or ratios one thing to another, right? So here on the left-hand side is the ratio of the moles of the acid to the base, but that is the ratio that you get from the equation. So this here is just theoretical. Okay, so that mole ratio on the left-hand side is the theoretical mole ratio that you get from your equation. It's not your actual moles that you have. On the right-hand side, this side is your actual values. If they say, you have hydrochloric acid of 0.1 molar concentration, then that you're going to put in on your right-hand side. Okay, so the right-hand side here is your actual values that they say this you add with this, blah, 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 blah. And this is just theoretically that you get from your balanced equation. Okay, so that is what I wrote down there. Let's see how we're going to use this. It says, in a titration, you hear titration, you think this. Okay. When I say science, you say? Okay, other way. When I say Marx, you say? Okay, whatever. When I say acid, you say? Ion. When I say titration, you immediately think of this equation. Immediately. You go write it down. 99% of the time you will use it. There's 1% that you will have to use another road, a back road. But most of the time you're going to use this or a version of this. Okay. Now, if you have extra classes somewhere else, at another school, they might not teach you this. Okay. And that's fine. You can use another path. This is the easiest way. Okay. But choose your path. Okay. If you prefer the way they teach it at another place, use that. It's not wrong. But don't mix the two. Okay. Because you will get confused. Okay. In a titration, you hear titration, you think this. So immediately, before I even read the next, I'm going to write, I need the mole of the acid, the mole of the base. Concentration, acid, concentration, base. Volume, acid, volume, base. Immediately. Obviously, you can line it up for yourself as well. Acid, 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 base, base, base. Doesn't matter. In a concentration, that of that is neutralized by that of that of that. Okay, highlighters. 12.3 of sulfuric acid is neutralized by so much of a, so these two fit together, so much of a this of potassium hydroxide. So that information goes with base, that information goes with acid. Determine the concentration of the acid. Okay, so here you need to take out your highlighters and you need to group the things together that fits together because it will get complicated. This is probably the most difficult chapter in your whole chemistry question paper. Okay, not because it's that difficult, it's because there's so much information you get confused. Okay, so acid I highlighted yellow. Acid, acid, acid. Base, base, base. Okay. Did I start with my questions? I feel I did. Democratso, give me anything I can put in my info table.
We have the acid for actual volume, which is 12.3 centimeters.
Yes. Okay. Now, do we work in centimeters cubed? No, we work in decimeters cubed. But, since this is a ratio, and since volume, they're going to cancel each other out. They can be in the same unit. But in June, I saw that if you have a question like this, they still want you to convert, even though things are going to cancel out. So let's rather convert. Technically, it can cancel out, but let's convert. Centimeters cubed, no decimeters, so times 10 to the power negative 3. What else? Is 20.5 again centimeters cubed, no, times 10 to the power negative 3. Putumelu. Yes, concentration of base is 0.3 moles per decimeters cubed. Oh, no, sorry, wrong place. Concentration of the base, 0.3. And they ask, what is the concentration of the acid? So that is the question mark there. Okay, but now I see there's lots of things happening here that I do not have. How am I going to get that?
Oh, we must use the equation.
No.
The equation that you have.
Where's your equation that you have?
Acid plus base.
You must write your own equation and balance it correctly.
Yes.
You can do that?
So it's H2.
It's potassium hydroxide.
No, it's actually
Okay, so you guys know something.
Maybe you're trying to hear me.
Yes, so this will be two solutions.
Okay.
Yeah. So aqueous. I'm quickly going to say, okay, 2SO4 because potassium is +1 and it gives you water. Then this is not balanced because 1 potassium, 2 potassiums. So this must be a 2 in front there and a 2 in front there. What do we call an acid again that has two? Not an acid that can donate two things? Diprotic acid. And we said if this is 2, then this will be 2. Yes? And then this will be 2.
Yes.
Sharp. Okay. So I want you to please, with the help of this equation, finish this one.
Finish which one?
Okay.
You get 2 answers.
Finish which one?
Now you must get one answer. Finish.
Or number 1. Okay.
Yeah. With this, use this equation. Okay? Then